Hi, here in this video we are going to discuss about the projections of square prism. Before reading the problem, we should know the how square prism looks like. Okay, this is the square prism. See, top and bottom two square faces are there. Okay, these two faces are joining with the help of rectangular faces. With the help of rectangular faces, then the square prism will be formed. Okay, see, this is the top face of the square, and this is the base, and these four are the rectangular faces. This is 1, 2, 3, and this. Okay, these four are the rectangular lateral faces. Okay, then by the intersection of diagonals, we will get the axis point on the top here, and the intersection of diagonals, we will get the one more axis point on the base at here. Okay, by joining axis point of the top face and base, we will get the axis. Okay, this is the axis. Okay, then these edges are called lateral edges. Okay, let's start read the problem. A square prism, 35 mm sides of base and 65 mm length, rest on HP on one of its edges of the base, which is inclined to VP at 30 degree. Draw the projections of the prism when the axis is inclined to HP at 45 degree. Okay, see, this is the given problem. By reading the problem, we know the details or conditions of all the positions. We will write conditions one by one. Okay, we know that the plane of projections, and see, we know that for first position, plane of projection and how does it rest on that plane, these two are required. Okay, see, here a square prism, 35 mm sides of base. Okay, see, just I will take the I will write the details one. Okay, the edge of the base, how much is there? 35 mm. Okay, na 35 mm, and 65 mm axis length of the axis is 65. Then rest on HP on one of its edges of the base. Okay, see, what is the plane here? Rest on HP, the plane is HP. Then one of its edges of the base, resting on edge of the base. Okay, these two conditions for initial position or first position. Then for second position, what is required? See, for second position here, for prism, axis is inclined to HP. This is given, this condition is given. Okay, see, just we check the in this problem here. See, which is inclined to VP at 30 degree. Draw the projections of the prism when the axis is inclined to HP at 45 degree. Same condition is there. Axis is inclined to HP at 45 degree. For second position, axis is inclined to HP at 45 degree. That is nothing but 2 HP means theta is 45 degree given, but axis is inclined. Okay, then for third position, okay, see, for third position, what are the conditions? Two conditions are given in the, usually two conditions are given. One is resting edge is inclined to HP. First we will check it this. Resting edge is inclined to VP or axis is inclined to VP. Any one is given. Okay, which is given? We will check in the problem. Here is given. Rest on HP on one of its edges of the base, which is inclined to VP at 30 degree. Which means what? Resting edge of the base is inclined to VP at 30 degree. Okay, resting edge of the base is inclined to VP at 30 degree. Okay, this condition is given for third position. Okay, these are the details for the first position, second position, and third position. Draw the horizontal thin XY line. Okay, this is the horizontal thin XY line. Write the VP above the XY line, HP below the XY line. Okay, now see, then after, since the plane is HP, okay, I start from first position, that is initial position. The plane is HP. since the base of the prism is placed on HP, that is nothing but axis here. This base of the prism is placed on horizontal plane HP. That is axis is perpendicular to VP, perpendicular to HP. Okay, perpendicular to HP, Okay, see, by looking from top, the top is look like as a square, correct? Now I want to draw the top view as a square. Okay, draw the top view as a square of 35 mm side, one side of base is perpendicular to XY line. One side of base is perpendicular to XY line. See here, just I will draw the square as a top view, that is below the XY line. Top view draw below the XY line, front view draw above the XY line. Okay, top view 35. See, this is the top view. Just I will make a dark line. Top view is the dark line. Okay, na? See. Now, okay. See, then after mark the axis point. Okay, by join the opposite corners, that is nothing but a diagonal. Draw the diagonal. Intersection of these two diagonals, that is the axis point. This is the axis point. Okay, this point is the axis point. The intersection of diagonals is the axis point. Okay, axis point of the square. Okay, now I want to give the name of the top view. Okay, name of the top view. It's very simple, is there? Top view names. Okay, see here, just top face names. Okay, top view of the prism is named as A, B, C, D, and base name or bottom face name as A1, B1, C1, D1. Okay, see, by looking from top, this top face is visible, correct? Now I want to give the name of the top face A, B, C, D. A, B, C, D. Okay, see, by looking from top here, what about this base? Base is exactly below the top face, hence it is invisible when observing or looking from the top. But we have to show this base. Okay, the base name as A1, B1, C1, D1. These are write it within bracket. Okay, write it, put it into the bracket. Okay, see, A visible, A1 within bracket. B is visible. What about B1 coincide with B? Then write it within bracket like this. C visible, C1 within bracket. D is visible, D1 within bracket. Okay, see here, A bracket A1, B bracket B1, C bracket C1, D bracket D1. Okay, see here clearly we show that, see, top view names are A, B, C, D without bracket, that is visible. A, B, C, D. Then bottom base names are not visible when you are observing here, that is within bracket A1, B1, C1, A1, B1, C1, D1. These are within the bracket. Okay, so this is the top view. See, next we will start. Okay, next this is the axis point. I will write it. This is O and bracket O1. bracket O1. Okay, the top view in this position we will be, okay, it will be, okay, see how it is look like front view. Okay, see here is the observer. When you are observing front, the front view will be a rectangle. Project the front view above the xy line, of height how much? 65 mm. That is nothing but length of the axis. Okay, see here, first I will project the top view upward direction of length how much? From the xy line of length 65. Okay, here 65. One, two, three, 4, 5, 6, 65. Okay, na? 65. Then axis. See, I think you know that how to show the axis. That is alternate large and shorter dashes. This is a thin line. Okay, this line is a thin line. Okay, now I want to give the name of the front view. Okay, where is the observer? Here is the observer. See, here we know that without bracket names are top face names, within bracket names are bottom names. Okay, this is first one. And the second thing is, here is the observer. Okay, see, here is the observer. Near points are visible. What are the points away from the observer? Those are invisible. Okay, when you are observing here, these points are visible. Okay, then these points are invisible. Okay, first I will name the top face corners. Okay, this is the top face. That is nothing but without bracket names are top face. Okay, by observing here, B is visible. Yes, B dash. What about A? A coincide with B. Write it within bracket A dash. Okay. Now C is visible. Write it C dash. D coincide with C within bracket D dash. This is top face name. Bottom face name are within bracket names are bottom face names. Okay. See, now here when you are observing B1 is visible, write it B1 dash. What about A1 coincide with B within bracket A1 dash. Now here C1 dash bracket D1 dash. See, these are the top names and this is the bottom names. Okay, this is the first position. Okay, here I am considering right side. Right side is the resting side. My right side is the resting side. For solids, considering right side is the resting side, it may be corner of the base or edge of the base. Okay, see, this is my right side is the this is the resting edge of the base, and in front view this is the resting edge of the front view. Okay, now see what is second condition. Axis is inclined to HP at 45 degree. Okay, axis is inclined. Okay, here tilt the front view such that resting edge, about the resting edge, see like this, let rotate like this about this resting edge. Okay, first mark the resting edge point on the x line. This is the resting edge in the top view. This is the edging, that is nothing but in front view. This point is the resting point or resting edge. Okay, just you mark it here, anywhere on here. Okay, just I mark it here. Mark it resting point. What is that? C1 dash D1 dash. Okay, now redraw this front view such that the base is the base is inclined at 90 minus theta degree to HP or XY line. See, just I will explain why we are taking 90 minus theta for base. Okay, see, if axis makes an angle 45 degree, then base makes an angle 90 minus 45, that is 45 degree. Okay, first I want to draw the base of angle 90 minus 45 degree. Okay, see, just I'll put it protractor on resting point, then measure the angle from this side. Okay, this is 45 degree. Okay, this is the 45 degree. Draw the base. Draw the base. Draw the base. Draw the base. Okay, this angle is 90 minus theta. Just I will explain why 90 minus theta. Okay, then base edge is, this base length is how much is there? That is 35. This base is how much is there? 35. What is the name of this point? This point is nothing but here, B1 dash bracket A1 dash. Now with the help of this base I redraw this front view. Redraw here. This is 90 degrees there here, and here also 90 degree. Okay, use protractor, take 90 degree. Then here also. Okay, length how much is there? 65. This length is how much? 65. Redraw or reproduce. Just I will extend this up to axis. Okay, where it is axis. Draw the thin line, thin chain type line. Oh, this name is, what is this name? B dash bracket A dash. This point is C dash bracket D dash. Okay, see, just to extend this axis, this angle is how much is given? 45 degree. See, this is perpendicular 90, 45. Then what about this angle? That is 90 minus theta or 90 minus 45. Okay, see, like this. This is right angle triangle. This angle is 45. And what about this? Right angle means 90 degree. What about this? 90 minus theta. Okay, see, now in this position I want to draw the corresponding top view. Okay, corresponding top view. By draw the horizontal projectors from the previous top view and vertical projectors downward from the front view. Okay, horizontal projectors and vertical projectors are intersecting. Mark the intersection point. See, first I project the horizontal projectors from the previous top view. See, okay, on this, what are the points are there? A1, B, D, D1. A horizontal is here. Okay, A horizontal. A and B, 2 points are there. This is A and B. Okay, na? Next, A1, B1, A1, B1, A1, B1. Okay, next, C1 D1, C1 D1, C1, where is C1 is here and D1 is here. Next CD, CD. Okay, just mark the all the intersection points of the horizontal and vertical projectors. Okay, see, after marking the intersection points, identify the visible and invisible edges. This is very important in solids. Okay, visible edges are shown as a continuation line or full line. Invisible edges are shown as dash lines. Okay, to identify the invisible portion or edges of the object, careful imaginative thinking is essential. Identification of visible and invisible edges, some thumb rules are used. What are those thumb rules? First rule is all outlines of every view are visible. Outlines of every view are visible. Hence outlines of all the views are shown as full lines. Okay, see here, where is the observer? Here is the observer. Okay, here is the observer. Since it is top view, observer is top of the object. Okay, by observing here, outline, first rule is outlines or boundary is always visible. Outlines is nothing but, see, start from A1 to B1 is the outline, B1 to C1 is the outline, then C1 to B is the outline, then C. Okay, this is the outline. Then C to D is the outline, then D to A is outline, D to A to D1, D to A1. Okay, this is complete outline or boundary. All outlines are visible. See, after this boundary there is no points lying outside of this boundary. See, no points lying outside this boundary. That is we consider as outlines. Outlines are visible. Okay, drawn as a continuation line. Okay, see, second rule is when you are observing here, what are the portions are near to observer, those portions are visible. What are the portions away from the observer or near to XY line, those are invisible. Okay, identify the point which is away from the observer. See, I am telling, identify the point which is away from the observer. See, which point is away from the observer is this point. See, compare all the points. Here is the observer, the point, this point is the away from the observer. Okay, then after, what are the lines passing through or touches this invisible point? Those are all invisible edges. Okay, for example, here there are 2 points are there in this point, C1 dash. Okay, C1 dash is here. There are 3 lines. Okay, C1 to C, this is one line. C1 to C is outline. Outline always visible. Okay, outline visible. Then C1 to D1, this is invisible. What are the lines passing? C1 and D1 dash, those are all invisible. Okay, then C1 to B1, for every point 3 lines are touches or passing. Okay, one line is C1 to C, first line outline is the visible. Second is C1 to D1, that is invisible. Then C1 to B1, that is outline is visible. Then consider D1 to D, outline visible. D1 to C1, already I have drawn invisible. Then D1 to A1, that is outline visible. Only this line is invisible. And third rule is remaining all lines are, whatever you left to draw the lines, those are all visible. See here, what are the lines are there? Only I left it this line. Okay, see, first thumb rule is all outlines are visible. Second one is identify the point which is away from the observer, that is invisible point. What are the lines passing through this invisible point? Those are all invisible. This is second one. Third one, remaining all lines are visible. Okay, this is the second portion. Okay, for third portion, the condition is resting edge of base is inclined to VP. redraw the top view such that resting edge C1D1 is inclined to VP at 30 degree. Okay, see which is resting edge here, C1D1. See, just I will explain how it is. C1D1 is the resting edge. In front view, this point is the resting point. Same point in the front view, in front view this point is the resting point. In top view, here this point, this line C1D1, this C1D1 is inclined 30 degree to VP. Draw 30 degree line here. Already I have drawn 30 degree line. Mark C1, mark it C1 here. Okay, mark it here C1. Then D1 to C1, how much is the length? Measure, then here to here. Okay, D1, this is the D1. This is rectangle, right? Rectangle is there, 90 degree. Measure 90 degree here. From here to here, how much is there? 90 degree, and from here also 90 degree. Okay, join, passes through the D1, draw the line, pass through the okay. Now you measure distance. This portion is above the line, this portion is below the line. Okay, mark this. This length is how much is there? See, you should maintain, it should be below the x1 line, like that you should draw it. It should not cross the xy line. Now this is invisible. Okay. See, then I left it here. Axis. Draw the axis line here. Then here also axis lines. I left the axis point. This is O dash O1 dash O dash O1 dash. Where it is? O1. Oh, this point is okay. Then after you draw this point also, measure distance, how much is there? You draw the one origin. Then distance from here to here, how much is there? O1. This is O1 and O. Okay, this I want to show this as a axis. Axis means alternate large and shorter dashes. Here also alternate large and shorter dash. Okay. Now I want to draw this required front view. Project all the points from the top view upward direction vertically, and from the this front view horizontally. Horizontal and vertical project are intersecting. Mark the intersection points. First I finish this base. Okay, na? See, next here A1 B1 on this horizontal line. A1, where is, okay, first I will give name. This is A1 B1 C1 D1 A B C and D. See, this top view should not touches the XY line, should not cross the XY line also. See, like that we should maintain the some space. Okay, we should maintain. Okay, A1 is here, and B1 A1 dash B1 dash. Then on this XY line C1 dash D1 dash, D1 and C1, D1 dash C1 dash. Then come to here, A and B on this horizontal line. A and B, from B, this point is A dash B dash. Then on this horizontal line, C dash and D dash, C dash and D dash. Sorry, C1 dash D C. This is C dash and D dash. Okay, see, just I am showing A1 dash B1 dash C1 dash D1 dash A dash B dash C dash and D dash. Okay, na? These are the points. Okay, see here, when you are observing here is the observer, see here also how to identify the visible and invisible edges. How to identify the visible and invisible edges, it's very important. See, some thumb rules are here. First thumb rule is draw all the outlines as a visible edges or full line. Okay, all the outlines. Outline means if I start A1 dash to D1 dash, then D1 dash to C1 dash, C1 dash to C dash. Next outline is our boundary. Next B dash. Next B dash to A dash. Then A dash to A1 dash. This is the boundary or outline. See, no one points lying out after this outlines or boundary. See, like this we have to draw. This is considered outlines. First, second one is when you are observing here, front face is visible. See, here is the observer. Near face or front face are visible. Which is front face here? A1, B1, C1, D1. This is visible. Okay, in this A1 dash, A1 dash, B1 dash, C1 dash and D1 dash. This space is nothing but this is visible. This is second one. Then in this space identify the non-boundary points. See, what do you meaning of non-boundary? The points which are not boundary, those are called non-boundary points. Okay, in this there are 4 points are there: A1 dash, B1 dash, C1 dash, D1 dash. Okay, you check the non-boundary points. A1 dash is the boundary. Okay, D1 dash is the boundary, C1 dash is the boundary. What about B1 dash is not boundary? See, it is inside the boundary. This we consider as a non-boundary point. What are the lines passing non-boundary points? Those are all visible. What are the lines passing through non-boundary points? Those are all visible. Okay, B1 dash to C1, one line, B1 dash to A1 dash. Already I have drawn these two lines. Then one more line, B1 dash to D dash. For every point there are 3 lines are passing or touches. Okay, 1, 2, 3. Okay, see second. See, what is second? Draw the front face as visible. See, like this. In this front face identify the non-boundary points. Non-boundary point means the points which are not a boundary. Okay, here non-boundary point is B1 dash. What are the lines passing non-boundary points? Those are all visible lines. Okay, then third rule is remaining all lines are invisible. What are the remaining lines? See, very simple. First, see, this is the base. This is the front face is finished. Then come to the A dash, B dash, C dash and D dash. Top face. A dash to B dash line is there, B dash to C line is there. Then C dash to D dash dash line, that is invisible. D dash to A dash dash line invisible. Remaining all lines are invisible. Okay na? Next come to the lateral edges. A1 dash to A dash line I have drawn, B1 dash to B dash line I have drawn, C1 dash to C line I have drawn. Then remaining one line is D dash to D1 dash. Okay, this is the invisible line. Okay, see, these are the thumb rules to identify the visible line for third portion. See, I am explaining. First is all outlines are visible. Second is by observing here, front face is visible. Draw the front face as visible. In this front face, identify the non-boundary points. After identify the non-boundary points, you find out the okay, what are the lines passing through those non-boundary points. Those are all visible. These three lines are visible. Then after, third rule is remaining all lines are invisible. Draw the whatever the lines you left it, remaining all lines are you draw as invisible. That is nothing but dash lines. Okay, after you draw the axis. Okay, axis here. Draw the axis. Here is the axis. O1 dash. O dash. Okay, you connect from here to here. This is the axis. Okay, see, this is the projection of square prism. Thank you.